Hello everyone. So, today we will study the classification of partial differential equations. So, many important processes in nature are governed by partial differential equation. So, it is very important to understand the physical behavior of this model governed by these partial differential equations. Also, this knowledge of the mathematical character, properties and solutions of the governing equations is required. So, we can classify this partial differential equation in two categories. One is physical classification and other is mathematical classification. In physical classification, we can classify as equilibrium problems and marching problems or initial value problem, and in mathematical classification we can classify the partial differential equation as hyperbolic PDEs, parabolic PDEs and elliptic PDEs. So, first let us see the physical classification. So, equilibrium problems. So, you have a domain, okay, which is represented by D and it is having the boundary, okay, it is boundary and this is represented by B. So, a solution of given PD is desired in a closed domain subject to a prescribed set of boundary conditions are known as equilibrium problems. So, in equilibrium problems you need to give the boundary conditions, okay, and the solutions are desired in this closed domain D. Okay. So, these are boundary value problems because you are specifying only boundary conditions and boundary condition must be satisfied on B and PDs must be satisfied in the domain D. Okay. So, you can see that steady state heat conduction equation, okay, steady state heat conduction equation. Okay. So, if you consider 2 dimension, then it is del 2 T by del x square plus del 2 T by del y square is equal to 0. Okay. So, here in this equation you can see that you need to solve this equation in the domain D and you need to specify the boundary condition. So, this is equilibrium problem. Similarly, incompressible inviscid flows. Okay. So, del 2 psi by del x square plus del 2 psi by del y square is equal to 0. It is in incompressible inviscid flow equation and this is also equilibrium problem. So, mathematically equilibrium problems are governed by elliptic PDEs. Okay, we will show later that mathematically if you see, so you can show that these equations are elliptic in nature. So, equilibrium problems are governed by generally elliptic PDEs. Next, marching problems. So, marching problems or these are known also as initial value problem. Initial, these are known as also initial boundary value problem. Boundary value problems. Okay. So, marching problems are tangent or tangent like problems where the solution in PD is required on an open domain subject to a set of initial conditions and a set of boundary conditions. Okay. So, look into this picture. So, this is your some initial data surface where t is equal to 0 and you are marching in time, okay, t, or so if it is tangent problem or tangent like problem. So, you can have some special direction x or y and you need to satisfy at each time instances these boundary conditions. Okay. So, boundary condition must be satisfied on this B and differential equation must be satisfied on in domain D. So, this is your domain. So, differential equation must be satisfied in D, boundary condition must be satisfied at the boundary and you need to specify some initial condition. Okay. Initial condition, if it is a tangent problem then at t is equal to 0 you need to specify the initial condition, or if it is tangent like problem then at x equal to 0 or y is equal to 0 you need to specify the initial condition. Okay. This is your initial condition. So, these are initial boundary value problem and open domain and marches in some direction time or some special direction, and it is subjected to initial as well as boundary conditions. Okay. So, later we will show that mathematically these problems are governed by either hyperbolic or parabolic equations, either hyperbolic or parabolic PDEs. Okay. So, let us consider one problem, one dimensional unsteady heat conduction problem. So, that you can write this equation, okay, del T by del T is equal to alpha del 2 T by del x square. Okay. If it is in 3 dimension, you can write in general like this, where alpha is the thermal diffusivity, and you can see that you need to march in time t, okay, and you need to specify the boundary conditions as well. Okay. So, you need a solution, okay, which must be satisfied in domain D. You need to specify the initial condition, because it is a time marching problem you can see here, and also you need to specify the boundary conditions. Similarly, tangent like problems, we have one example, that is boundary layer equation. Okay. So, boundary layer equation you can write u del u by del x plus v del u by del y is equal to nu del 2 u by del y square, where nu is your kinematic viscosity. So, this boundary layer equation is also parabolic in nature. Okay. If you mathematically see, this equation will be parabolic in nature, and this you need to march in the direction x. Okay. So, in here x is the marching direction. So, if you see, you have say flow over flat plate, okay, and you have this boundary layer, let us say, okay, and you need to solve this in a domain. Let us say this is your domain, then this is your x equal to 0, this is x equal to L, okay, y is equal to 0 and y is equal to h. Then at x equal to 0, you need to specify the initial condition. Okay. So, at x equal to 0, you give the initial condition, and in y direction you give the boundary conditions. Okay. You need to give the boundary condition in y direction. So, you can see, although time derivative is not there, but it is a initial boundary value problem or marching problem, and the marching direction is x. So, it is a tangent like problem, and if you have a time derivative, obviously it is a time marching problem in the direction time. So, we have discussed about the physical classification, okay, equilibrium problems and marching problems. Now, let us discuss about the mathematical classification. Mathematical classifications. So, first we will consider in general a second order partial differential equation, second order partial differential equation. Let us take in general as A del 2 phi by del x square plus B del 2 phi by del x del y plus C del 2 phi by del y square plus D del phi by del x plus E del phi by del y plus A phi is equal to G. So, this is in general we have written one second order partial differential equation, and you know when it is called linear and non-linear, and when it is homogeneous non-homogeneous. So, you can see the coefficients A, B, C, D, E, F, these are the coefficients. If these coefficients, okay, are functions of only x y, or these are constants, then this is known as linear equation. Okay. Linear equation, then it will be linear equation. So, the coefficients are constants or only function of x y, then this will be called as linear equation, otherwise it is non-linear. Okay. And if g is 0, then it is homogeneous, otherwise it is non-homogeneous. So, if this g, okay, g is equal to 0, then this is known as homogeneous equation, otherwise it is non-homogeneous equation. So, generally the mathematical classification of this PD will depend on the highest order derivative in each independent variables. So, you can see in this governing equation highest order is second order. So, we can classify based on this second order derivative. So, we can write this equation. Okay. So, the classification depends only on the highest order derivative, highest order derivatives in each independent variable. Okay. So, now we can write this equation in a modified form. Okay. So, rewrite the above PD in modified form, which contains only the highest derivative, modified form. So, we can write A del 2 phi by del x square plus B del 2 phi by del x del y plus C del 2 phi by del y square is equal to H. So, now we mathematically we can classify as, if this coefficient you know A, B, C, okay, these are the coefficient. If b square minus 4 AC less than 0, then it is elliptic. If b square minus 4 AC equal to 0, then it is parabolic, and if b square minus 4 AC greater than 0, then it is hyperbolic. Okay. So, if you consider a second order PD and considering the coefficient of highest derivative, if b square minus 4 AC is less than 0, then it is elliptic. If b square minus 4 is AC is equal to 0, then it is parabolic, and if b square minus 4 AC is greater than 0, then it is hyperbolic in nature. Let us take one example, simple example. So, that is your steady state heat conduction equation. Okay. Let us consider 2D. Okay. So, what is that equation? You know, del 2 T by del x square plus del 2 T by del y square is equal to 0. Okay. Physical classification, you know, what is the physical classification? So, you know that it is a equilibrium problems. Now, let us see the coefficients. So, if you compare this with this equation, okay, whatever we have written, then what you can get? So, we can write the coefficient A is equal to 1. Okay. The mixed derivative, it is 0 coefficient, because mixed derivative does not appear here. So, B should be 0 and C is equal to 1. Okay. So, we could write the coefficient, there is no mixed derivative. So, B is equal to 0 and A is equal to 1 and C is equal to 1. So, now find B square minus 4 AC. Okay, what is B square minus 4 AC? B square minus 4 AC is equal to 0 minus force, that means minus 4, which is less than 0. So, based on our definition, you can say that this is elliptic in nature. So, this is elliptic in nature. So, mathematically now you can see this 2D steady state heat conduction equation is elliptic in nature, and physically it is equilibrium problems. Now, let us consider one dimensional unsteady heat conduction equation. Okay. So, 1D unsteady heat conduction equation. Okay. So, 1D unsteady heat conduction equation. So, del T by del T is equal to alpha, which is your thermal diffusivity, del 2 D by del x square. So, physically this is a marching problems. Now, let us see what is the mathematical character of this equation. If you see the coefficients, then it is actually alpha del 2 T by del x square is equal to del T by del T. So, you can see the coefficients. Okay, A is alpha, there is no mixed derivative, B is equal to 0, okay, and there is no del 2 phi by del y square. So, that means C is equal to also 0. So, these are the coefficients, okay. And if you find B square minus 4 AC, okay, so it will be 0, okay, and minus 4 AC. So, it is 4 alpha into 0, that means it is 0, okay. And we have learned that if B square minus 4 AC is equal to 0, then it is a parabolic equation. So, it is a parabolic equation. So, mathematically this equation is parabolic in nature, and physically it is a marching problem. Next, let us consider wave equation, okay, second order wave equation. Second order wave equation. Okay. So, we are considering second order partial differential equations, okay, because we are classifying based on this second order partial differential equation what we discussed in earlier slides. So, we are considering del 2 u by del t square is equal to c square del 2 u by del x square. Okay. So, this is the second order wave equation. Now, we can write it as del 2 u by del t square minus c square del 2 u by del x square is equal to 0. Okay. So, now see the coefficients. Okay. You can write a is equal to 1, there is no mixed derivative. So, b is equal to 0 and c is equal to minus c square, okay, minus c square. C is the wave speed, okay, c is the wave speed, okay. So, this is coefficient and this is your wave speed. So, now you can write b square minus 4 ac is equal to 0 minus minus 4 into 1 into minus c square, that means it is 4 c square, which is greater than 0. Okay. So, b square minus 4 ac is greater than 0, then obviously it is hyperbolic in nature. So, mathematically it is hyperbolic in nature, and physically it is marching problem. Okay. So, now we consider 3 different second order PDEs. One is 2 dimensional heat conduction equation, which is elliptic equation. Then we considered 1 dimensional unsteady heat conduction equation, that is parabolic equation, and then we considered second order wave equation, and it is hyperbolic equation. Now, let us consider another equation which is known as Tricomi equation. Tricomi equation. Okay, it is represented as del 2 u by del x square minus x del 2 u by del y square is equal to 0. So, now find the coefficients. So, a is equal to 1, there is no mixed derivative. So, b is equal to 0 and c is equal to minus x. Okay. So, now you can write b square minus 4 ac is equal to 0 minus 4 into 1 into minus x. Okay. So, it is 4x. Okay. Minus minus plus, so it will be 4x. Okay. So, now you can see that the value of b square minus 4ac will depend on the value of x. Okay. So, x can be 0, x can be positive or x can be negative, and depending on the value of x you will get different mathematical character of this equation, right. So, you can see if it is 4x, if x equal to 0, what you are going to get? You are going to get b square minus 4ac is equal to 0, right. So, that means it is parabolic in nature. So, it is parabolic. Then if x greater than 0, okay, if x greater than 0, then you will get b square minus 4 ac as greater than 0 and it will be hyperbolic. And if x less than 0, then b square minus 4 ac also will be less than 0, okay, and you will get elliptic. So, you can see this trigonometry equation, the mathematical behavior will depend on the value of x and it will change its behavior depending on the value of x. So, it may be elliptic, parabolic or hyperbolic. Let us consider another equation. Okay, so, that is known as steady for steady compressible flows. Okay, so, you can write 1 minus m infinity square, where m infinity is your Mach number, del 2 phi by del x square plus del 2 phi by del y square is equal to 0. Okay. M infinity is Mach number. Okay. So, now you find the coefficients. Okay, here there is no mixed derivative. So, b will be 0 and a will be 1 minus m infinity square and c will be 1. So, a is 1 minus f m infinity square, b is 0 and c is 1. So, you will find b square minus 4 ac is equal to 0 minus 4 1 minus m infinity square into 1. Okay. So, it will be minus 4 1 minus m infinity square. So, you can see that b square minus 4 ac depends its sign depends on the value of m infinity. Okay. So, if m infinity is 0, for m infinity is 0, that means it is incompressible flow. Okay. Incompressible flows. So, if infinity is 0, what will be b square minus 4 ac? It will be minus 4, okay, which is less than 0, okay, less than 0. So, it will be your elliptic in nature. Elliptic. Okay. And if for m infinity is equal to 1, m infinity is 1, then you will get b square minus 4 ac is equal to 0. So, it will behave as parabolic. Okay, so let us consider two different kinds of flow. One is subsonic flow and supersonic flow. So if we consider supersonic flow, then m infinity will be greater than 1. Okay. So if m infinity greater than 1, so you can see, so it will be negative and this negative will be positive. So b square minus 4 ac will be positive and it will be greater than 0. Okay. So if it is greater than 0, then obviously it is hyperbolic in nature. So it is hyperbolic. And if you consider subsonic flow, so it will be m infinity less than 1. Okay. So if m infinity is less than 1, so you can see in this expression, if it is m infinity is less than 1, then this itself will be a positive. Okay. 1 minus m infinity square will be positive and b square minus 4 ac will be negative. So that means it is b square minus 4 ac will be less than 0. Okay. And it will be elliptic in nature. Okay. So now you can see for this particular equation, depending on the value of infinity, you are getting different mathematical character of this equation. If m infinity is 1, then b square minus 4 ac is 0. So obviously it is becoming parabolic in nature. If m infinity is 0, then you can see it will be less than 0, then it will be elliptic in nature. But for supersonic and subsonic flow, depending on the value of m infinity, you are getting hyperbolic if m infinity is greater than 1, and if it is m infinity is less than 1 for subsonic flow, then it will become elliptic. So now we have seen this second order PD, and depending on the highest order derivative, we have classified this equation mathematically, and it can be elliptic, parabolic and hyperbolic depending on the value of b square minus 4 ac. Okay. So can we reduce this PD to OD, okay, and can we see the characteristic lines or curves, okay, of these equations. Okay. So we had equation A del 2 phi by del x square plus B del 2 phi del x del y plus C del 2 phi by del y square is equal to h. Okay. It is a second order PD. So now can we reduce this PD to OD? Okay. So now to reduce it, let us say this equation is 1. Let us take P is equal to del phi by del x and Q as del phi by del y. Okay. So we can write dP as del p by del x into dx plus del p by del y into dy. Okay. So and also you can write dp by dx is equal to del p by del x plus del p by del y into dy by dx. Okay. So you can see del p by del x, what you can write in terms of phi. So p is del phi by del x, so del p by del x will be del 2 phi by del x square plus and del phi by del y. So obviously if you take del p by del y, so it will be del 2 phi by del x del y. So you can write dy by dx del 2 phi by del x del y. Okay. Similarly, if you write dq is equal to del q by del x dx plus del q by del y dy. Okay. And you can write dq by dy is equal to del q by del x plus dx by dy will be, so it will be dx by dy plus del q by del y. Okay. So, q is del phi by del y. So, del q by del x, if you take the derivative with respect to x of this of this q is equal to del phi by del y, then you will get dx by dy as del 2 phi by del x del y, and if you take del q by del y, then you will get del 2 phi by del y square. Okay. So, now let us take a dp by dx plus c dq by dy. Okay. So, dp by dx, this is the expression, dq by dy, this is the expression, you put it, then rearrange, what you will get. So, it will be a del 2 phi by del x square plus dy by dx del 2 phi by del x del y plus c into del q by del y. So, it will be dx by dy del 2 phi by del x y del x del y plus del 2 phi by del y square. Okay. So, if you see the right hand side, so you can write a del 2 phi by del x square plus a dy by dx, okay, plus c dx by dy, okay, into del 2 phi by del x del y plus del c into del 2 phi by del y square. So, now you can see, so a del 2 pi by del x square plus some coefficient into mixed derivative plus c into del 2 pi by del y square. So, left hand side we have OD. Okay. So, when it you can reduce it to this PD to OD. So, if this a del dy by dx plus c dx by dy, if it becomes b, okay, then you can write this equal to h. So, if you can write it as a d2 phi by dx square plus b. So, this term together if you can write as b del 2 phi by del x del y plus c del 2 phi by del y square. Okay. Okay, if you can write comparing, so if it is equation 2, so comparing equation 1 and equation 2, okay, we could write this, then it will be equal to h. Okay. So, in a certain condition you can actually reduce this PD to OD, provided here you have a dy by dx plus c dx by dy is equal to b. Okay. So, in this condition you can reduce this PD to OD, because now you are getting the OD as a dp by dx plus c dq by dy is equal to h. Okay. So, that you are getting. So, this is, you can see, this is your OD, okay, and this is your PD. So, this PD you can write, okay, OD with the condition a dy dx plus c dx by dy is equal to. Now, if a dy by dx plus c dx by dy is equal to b, if you rearrange it, then you can write a dy by dx plus c dx by dy minus b is equal to 0. Now, you multiply with dy dx. So, you can write a dy by dx square. So, you are multiplying with dy dx. So, it will be c minus b dy by dx equal to 0, or you can write it as a dy by dx square minus b dy by dx plus c is equal to 0, and you can find the value of dy dx, okay, which is the slope of the curve, okay, which is the slope of the curve. You can write dy dx as b plus minus b square minus 4 ac divided by 2a. Okay. So, now you can find the slope of this curve dy dx, okay, as b plus minus b square minus 4 ac by 2a, and this dy dx is known as curves of the characteristics. Okay. So, it is characteristics. The characteristics are paths in the solution domain along which information propagates. Okay, information propagates, and for this particular situation, these characteristics are lines along which PD will be reduced to OD, because we started with PD, and with this condition dy by dx is equal to b plus minus root b square minus 4 ac by 2a, you can see that characteristics are lines along which PD will be reduced to OD. So, now we will see how we can classify mathematically seeing the characteristics. So, dy by dx is equal to b plus minus root b square minus 4 ac divided by 2a. Okay. So, if you have real and distinct characteristics, okay, okay, then this will be mathematically hyperbolic equation. Okay. Then if you have imaginary or complex characteristics, imaginary or complex characteristics, then it will be elliptic equation. And if you have real and repeated characteristics, then you have parabolic equation. Okay. So, first you have to find the characteristics. So, if you find that you have real and distinct characteristics, okay, then it will be hyperbolic in nature, and if it is imaginary or complex characteristics, then you will get elliptic in nature, and if you have real but repeated, okay, then you will get parabolic in nature. So, now from here, now you can see when it will become real and distinct. Okay. So, this discriminant b square minus 4 ac you just see. Okay. So, if b square minus 4 ac, if it is greater than 0, then only you will get a real and distinct characteristics. Okay. So, if b square minus 4 ac is greater than 0, then this characteristic will be real and distinct. That means, b square minus 4 ac for this second order PD already we have discussed that it will be hyperbolic. Okay. and when it will become imaginary complex if b square minus 4 ac is less than 0, right. So, b square minus 4 ac if it is less than 0, then you will get imaginary characteristics. So, it will be elliptic, and when you will get repeated real and repeated, if b square minus 4 ac is 0, then you will get b square minus 4 ac is 0, then you will get parabolic. Okay. So, now converting this PD to OD with a certain condition, we have shown that characteristic dy by dx we have expressed in terms of the coefficients ABC, okay, and this is the relation, okay, b plus minus root b square minus 4 ac by 2a. So, dy dx is the characteristic. So, this characteristic you have represented in terms of the coefficients ABC, okay, of the second order PD. Okay. So, now we have defined when it will become hyperbolic, parabolic and elliptic, seeing the nature of the characteristics, and you can see now you can correlate it what we defined in the beginning, that b square minus 4 ac if it is greater than 0, then only you will get real and distinct. So, you can write it is hyperbolic without seeing the characteristics, then b square minus 4 ac less than 0, then elliptic, and if b square minus 4 ac is 0, then you will get only real and repeated characteristics, then it will be parabolic in nature. Now, let us consider the second order wave equation. Okay. Wave equation. So, what is that equation? It is del 2 phi by del t square, or del 2 u, let us write del 2 u by del t square is equal to c square del 2 u by del x square. C is the wave speed, c is the wave speed, and if you write the coefficients, let us say c square del 2 u by del x square minus del 2 u by del t square is equal to 0, then your coefficient A is c square, there is no mixed derivative, b is equal to 0 and c is minus 1. Okay, we have shown that b square minus 4 ac we have shown b square minus 4 ac is your it is your 4 c square, okay, which is greater than 0, okay, and it is hyperbolic in nature. So, now let us find the characteristic of this equation. Now, here you have x and t, right. So, you will write dt by dx, okay, dt by dx, because earlier we have written dy by dx because it was del 2 u by del y square. So, now you are writing dt by dx, which is the characteristic as b plus minus root b square minus 4 ac divided by 2a. Okay. So, now what is b? B is 0 plus minus, so it is 0 minus 4 ac, so it will be plus 4 c square, okay, divided by 2a. So, it will be 2a means 2 c square. So, it will be, so 2 c, so it will be plus minus 1 by c. Okay. So, dt by dx is plus minus 1 by c. So, you can see you have a real characteristics and distinct characteristics, okay, because one you have 1 by c and another you have minus 1 by c. So, these are the real and distinct characteristics. Now, if you plot it in so, this is x and this is your t. Okay. So, if you see if you plot 1 by c, if you plot, then you will get the curve as like this, okay, because you will have the slope. Okay. So, if it is 1 and it is 1 by c, if it is 1 by c, then dt by dx will be 1 by c. And similarly, if you see for this minus 1 by c, then it will be like this, okay. And the slope, you can see slope is, this is your 1, this is minus 1 by c, okay. So, two characteristics, okay. So, here you can see that you will get right, this is your right travelling waves and you will get left travelling waves, and at any point p if you consider, okay. So, you can have two characteristics, okay, one with positive slope and another with negative slope, okay. And the solution at point p is dependent on only solution of a finite region. So, you have real characteristics, okay, and you have finite domain of dependent and influence, okay. So, you have domain of influence is this one, okay, because this is your domain of influence, and this is your domain of dependence. So, this is your domain of dependence. Okay. Next, let us consider the heat conduction equation. So, if you consider unsteady heat conduction equation, so we have del T by del T is equal to alpha del 2 T by del x square. So, if you see, so it will be A is equal to alpha and B and C are 0. So, what will be your dt by dx? So, dt by dx if you put it, it will be 0. Okay. So, you have a single characteristic and its value is 0. So, single characteristics and you have time dependent diffusion. If you plot it in the Tx plot, okay, so this is your x, this is your t. So, dt by dx is 0, right, dt by dx is 0. So, you will get the curve as this. If this is the point P, then the solution of point P will influence the solution of all points t greater than t1. If it is t1, okay, so the solution of point P will influence the solution of all points at t greater than t1, and the solution of P will be dependent on the solution of all points t less than t1. Okay, the solution of P will be dependent on the all solution, okay, on the solution of all points which is t less than t1. Okay. And next, let us consider the elliptic equation, okay, which is your steady 2D equation, heat diffusion equation, 2D heat diffusion equation. So, del 2 t by del x square plus del 2 t by del y square is 0. Okay. So, you will get A is equal to 1, B is equal to 0, C is equal to 1, and if you see the characteristic dy by dx is your plus minus 2y. So, you can see these are imaginary characteristics. So, obviously, it is elliptic in nature. So, if it is elliptic in nature, so the domain of, so if you see this is your x and this is your y, and you have this is the domain, and if any point P, then the domain of dependence and domain of influence is the entire domain, okay, entire domain, and it is a equilibrium problem. So, here the domain of dependence and domain of influence is the entire domain. What does it mean? So, if you see the solution of P, okay, if you propagate it will go in all direction. Okay. So, obviously, domain of dependence and domain of influence will be the entire domain. Okay. So, with that, now see what is well posed problem. Okay. So, to solve a PD with initial condition and or boundary condition, it has to be a well posed problem. What is well posed problem? So, well posed problem, if the solution must exist, solution must be unique and solution must be stable. Okay. Then you can say that it is a well posed problem. Now, in summary, so let us see the comparison of elliptic equation, parabolic equation and hyperbolic equation. So, we have taken this 2 dimensional heat conduction equation, steady state heat conduction equation, 1 dimensional unsteady heat conduction equation, and also we have considered second order wave equation. So, which is hyperbolic in nature. So, you can see that for the elliptic equation no real characteristic line exists, because we got imaginary characteristic. For the parabolic equation only one characteristic line exists, right. So, that we have shown. So, dt by dx is 0, and for the hyperbolic equation we have shown that two characteristic line exists. Okay. So, dt by dx is equal to plus minus 1 by c we have shown. In case of elliptic equation, if you disturb, so that disturbance propagates in all direction. In case of parabolic equation, a disturbance propagates along the characteristic line, and here for hyperbolic equation a disturbance propagates along the characteristic lines. Okay. For the elliptic equation, domain of solution is the closed regime, okay, but for parabolic and hyperbolic equation domain of solution is an open regime. And for elliptic equation boundary condition must be specified on the boundaries of the domain. For parabolic equation an initial condition and two boundary conditions are required, but for hyperbolic equation two initial conditions along with two boundary conditions are required. In today's lecture, so we have seen the mathematical and physical classification. So, in physical classifications we have categorized in two ways. One is elliptic problem, equilibrium problem and marching problem. So, equilibrium problems are generally elliptic in nature and marching problems are parabolic or hyperbolic in nature. And in mathematically we have categorized as elliptic equation, parabolic equation and hyperbolic equation. First, depending on the coefficient b square minus 4ac, we have seen if it is less than 0 then it is elliptic in nature, if it is b square minus 4ac is 0 then it is parabolic in nature, and if b square minus 4ac if it is greater than 0 then it is hyperbolic in nature. Then we have found the characteristic lines dy by dx, and based on that we have defined if two real and distinct characteristics are there then the equation is hyperbolic in nature. If you have real and repeated characteristics, then it is parabolic in nature, and if you have real and imaginary characteristics, then it is elliptic in nature. Thank you.